Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss chemistry lesson redox reaction part 2. Before we begin today's class, we request you to subscribe, like and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin today's class. In the last class we have done oxidation, reduction, redox reactions, their examples of classical theories of oxidation and reduction, and in this class we have also done how to find out the oxidation number or oxidation state of an element in a given compound. In today's class we'll study about the oxidation and reduction concept in terms of oxidation number. So what is oxidation in terms of oxidation number? Oxidation is a chemical change in which there is an increase in oxidation number. So increase in oxidation number is called oxidation. And opposite to it, decrease in oxidation number is a reduction. Let us see an example. So this is a redox reaction. Zn plus 2HCl gives ZnCl2 plus H2. In this we can see Zn, the reactant Zn, have a oxidation number as 0, but in the product while forming ZnCl2, Zn has a plus 2 oxidation number or oxidation state. So here what is happening? Increasing in oxidation number. So in this case for Zn there is an increase in oxidation number, so it is oxidation. On the other hand, for hydrogen the oxidation number is decreased from plus 1 to 0, so it is a reduction. So oxidizing agent in terms of oxidation number, oxidizing agent is a substance which increases the oxidation number of other substance in a chemical reaction, and oxidation number of oxidizing agent decreases. Reducing agent, reducing agent is a substance which decreases the oxidation number of other substance in a chemical reaction, and oxidation number of reducing agent increases. So let us take an example. Here in the given reaction, Mn2 plus 3Mn2 plus 4Al gives 3Mn plus 2Al2O3. Here Mn oxidation number is Mn2. In Mn2, Mn's oxidation number is decreased to from plus 4 to 0. So here MnO2 is reduced. On the other hand, aluminum's oxidation number is increased from 0 to plus 3. Therefore, aluminum is oxidized. Thus, aluminum acts as a reducing agent and Mn2 acts as an oxidizing agent, because what Mn2 does is it increases the oxidation number of aluminum. MnO2 increases the oxidation number of aluminum, so it is a reducing agent. it is an oxidizing agent. On the other hand, Al decreases the oxidation number of Mn in MnO2. So Al acts as a reducing agent. So again repeating the same, that MnO2 increases the oxidation number of aluminium. So MnO2 is an oxidizing agent. On the other hand, aluminium decreases the oxidation number of MnO2 of Mn from in MnO2. Therefore, aluminium is acting as a reducing agent. Let us see one more problem for oxidation state. The question is the ratio of oxidation state of Br in potassium bromide to that of potassium bromate is A. Options are given, 4 options are given. A is equal to plus 1 by 5, B is equal to minus 1 by 5, C is equal to minus 2 by 5, D is equal to plus 3 by 5. So oxidation state of bromine in KBr potassium bromide is minus 1. Oxidation state of Br in KBrO3, that is potassium bromate, is plus 5. How? It is very simple. Potassium oxidation state is plus 1. Oxygens or one oxygen oxidation state is minus 2. So 3 oxygens. So we can write is plus 1 plus bromine. Let us say bromine is X, and 3 oxygen, 3 multiplied by minus 2 is equal to 0. Therefore, upon solving, we get 1 plus X plus minus 6 is equal to 0. Then X minus 5 is equal to 0. X is equal to 5. So this is the 5 we got here. So the ratio of both of them is 1:5. Therefore, B, and option B is correct in this case. Let us see the next topic. So next topic is more than one oxidation state. The compounds of metals which shows more than one oxidation state are distinguished from one another by placing a Roman numeral indicating the oxidation state of that metal. So how we do? Let us take an example of iron chloride. So here the oxidation state of iron is 2. So we have written 2 as a Roman numeral here. And in the second case, FeCl3, oxidation state of iron is 3. So Roman numeral 3 is written here. In this way, we represent the oxidation state, more than one oxidation state. Now various types of redox reactions. So first type is combination reaction. So it is very simple. The chemical reaction in which two or more substances combine to form a single substance is called combination reaction. So it can be written as the type A plus B combines to give AB. So we can see an example of this type as carbon plus oxygen gives carbon dioxide, where oxidation state of carbon is 0, oxygen is also 0, but here in the product oxidation state of carbon is +4 and oxidation state of oxygen is -2. Similarly, Fe plus S gives FeS. Here also oxidation state of iron is 0 and sulfur is 0 but in the reactant, but in the product oxidation state of iron is +2 and oxidation state of sulfur is -2. The next type of reaction is decomposition reaction. So the chemical reaction in which compounds breaks up into two or more simple substances are called decomposition reaction. For example, hydrogen on heating, it gives hydrogen gas and oxygen gas. So oxidation state of hydrogen is +1, oxidation state of oxygen is -2 in the reactant, but in the product the oxidation state of hydrogen is 0, oxidation state of oxygen is 0. Note, all decomposition reactions are not redox reaction. For example, calcium carbonate on heating, it gives calcium oxide and carbon dioxide. It is not a redox reaction. Displacement reaction, the reaction in which one ion of a compound is replaced by an ion of other element, are called displacement reaction. Displacement reaction can be of two types. So first let me explain the displacement reaction form. Say a compound XY is there which is added to with Z, then X and Z Y. So X is displaced by Z. So the reaction in which one ion of a compound is replaced by an ion of other element is called displacement reaction. This is the type of displacement reaction. So there are two types of displacement reaction: metal displacement reaction and non-metal displacement reaction. So metal displacement reaction, in this reaction a metal in a compound is displaced by some other metal. For example, CuSO4 copper sulfate plus zinc gives zinc sulfate plus copper. Here zinc replaces copper from copper sulfate to form zinc sulfate. So this is an example of metal displacement reaction. Now non-metal displacement reaction. The non-metal displacement redox reactions are mainly hydrogen or oxygen displacement reactions. So let us see in detail. So example type 1, all alkali metals and some alkaline earth metals displace hydrogen from cold water. For example, 2Na plus 2H2O gives 2NaOH and hydrogen H2. So here alkali metals displace hydrogen from cold water. Example type 2, less reactive metals reacts with steam to produce hydrogen gas. For example, magnesium plus 2H2O gives magnesium hydroxide plus hydrogen. Here magnesium displaces hydrogen from the steam. So third, many metals, including those which do not react with cold water, displace hydrogen from acids. So metals reacts with acid to give hydrogen. So for example, zinc reacts with HCl to give zinc, zinc chloride, that is ZnCl2 plus hydrogen gas. Similarly, zinc reacts with H2SO4 to give ZnSO4 zinc sulfate plus hydrogen gas. Now, the fourth type of redox reaction is disproportionate or disproportionation reaction, a reaction in which the atom of same element is simultaneously oxidized as well as reduced are called disproportionation reaction. Example: phosphorus, sulfur and chloride undergoes disproportionation reaction in alkaline medium. For example, P4 plus 3OH minus aqueous solution gives pH3 plus 3H2PO2. Similarly, S8 plus 12OH gives 4S minus 2 plus 2S plus 2, 2S2O3. So this is the sulfur example for disproportionation reaction, and the last example is for chlorine. Chlorine plus 2OH minus gives ClO minus plus Cl. These are the example of disproportionation reaction. Fractional oxidation state. In certain compounds, oxidation number of a particular element is in fraction. For example, carbon suboxide. So here we can see in the structure that in C3O2 the oxidation number of 2 carbon atom is in the terminal position is plus 2, while that of atoms present in the center is 0. The average oxidation number of carbon atom is 2 plus 2 plus 0 upon 3, that is 4 by 3, which is in fraction. In the last, if you remember, in the last class we have done a example of oxidation number which is in fraction. So this is the details. Today in this class we are going little more details about fractional oxidation number. We'll see a couple of more examples in this. Let us see one more example: tetrathionate ion, that is S4O6 minus 2. The structure is shown below. The average oxidation number of sulfur atom in this ion is 5 plus 5 plus 0 plus 0 plus 4, that is 2.5, or you can write 5 by 2. The same example we have done in the last class. The third example is tribromo octoxide, that is Br3O8. If we draw the structure, we can see that the oxidation number of bromine atom two of the bromine, the first and the last bromine atom is +6, but oxidation number of the central bromine atom is +4. So the average oxidation number is 6 plus 6 plus 4 upon 3, that is 16 upon 3. Now balancing of redox reaction. This is very important concept. Direct questions are asked and indirectly you have to uh, balance the equation, then you have to solve the further problem. So indirectly use this concept, balancing of equation is used, and direct questions are also comes in IIT, NEET and other engineering and medical examinations. So let us see one of the example. Mg plus HNO3 gives MgNO3 whole 2 plus N2O plus H2. So we'll balance this equation with the first method, that is oxidation number method. So there are few steps. Please follow the steps. In step 1, what we do, we write the equation and we put the relative oxidation number above each element. So oxidation number for Mg is 0. Oxidation number of nitrogen N in HNO3 is +5. Oxidation number in the product, so reactant is completed now. Now product. In product MgNO3 whole 2, the oxidation number of Mg is +2. Oxidation number of N is +5 in MgNO3 whole 2. Oxidation number of N2O is +1, and that's it. This is the step 1. In step 2, we will write the total change in oxidation number. So we can see the oxidation number of Mg changes from 0 to +2, that is oxidation number increased by 2 unit. On the other hand, oxidation number is decreased by 4 unit for nitrogen. Total change in oxidation number is equal to 4 into 2, 2 nitrogen atoms, so 4 into 2, that is 8. In step 2, what we write? The total change in oxidation number. Now comes step 3. In step 3, Mg equation is multiplied by 4 and HNO3 equation is multiplied by 2. Why 2 and 4? From where 2 and 4 came? So it came from step 2, where if we see the change in oxidation number. So in HNO3 reaction, we have change in oxidation number as 4. So Mg equation is multiplied by 4. It is cross multiplication. And on the other hand, equation in Mg equation, oxidation number is changed by 2. Therefore, HNO3 equation will be multiplied by 2. So crossly it will be multiplied. So after multiplication, we got Mg equation is multiplied by 4, so we get 4 Mg, and HNO3 equation is multiplied by 2, so we get 2 HNO3 is equal to 4 MgNO3 whole 2 plus N2O plus H2O. This is step 3. We crossly multiplied by the change of oxidation number each equations. Now step 4. In step 4, we balance all the atoms other than oxygen and hydrogen. So here we have here first nitrogen, we have balanced nitrogen, we have balanced magnesium uh, and other elements, except hydrogen and oxygen are not balanced, which we are going to balance it in step 5. In step 5 we balance hydrogen and oxygen by adding H2O molecules. So extra number of H2O molecules are added in the product, and hydrogen and oxygen are balanced. So this is how we balance a redox reaction with the help of or with oxidation number method. This is very important, so will give some more time to review this process again. So we have to balance the equation Mg plus HNO3, MgNO3 whole 2 plus N2O plus H2O. So step 1, there are 5 steps to balance this equation. So in step 1 we write the oxidation number above the elements. So Mg is oxidation number is 0, N's oxidation, nitrogen's oxidation number in HNO3 is plus 5. In the product, Mg's oxidation number is plus 2, and in nitrogen oxidation number is plus 5, and in NO2 oxidation number is plus 1. Now in step 2 we will write the change in oxidation number. So Mg's oxidation number increases by 2 unit, nitrogen oxidation number is decreased by 1 unit, by 4 unit. This is step 2. In step 3 we crossly multiply, so with the change in oxidation number. Since magnesium oxidation number changed by 2 units, so we'll multiply with 2 the HNO3 reactions. HNO3 equation. Similarly, HNO3 in HNO3 nitrogen's oxidation number decreased by 4, so we'll multiply that 4 with Mg equation, and upon multiplying we get the following result. In step 4 we balance all the elements other than hydrogen and oxygen, and in step 5 we balance the hydrogen and oxygen by adding water molecules, and this is the 5 step for balancing equations by oxidation number. Now we'll study balancing equation by ion electron method. So let us see an example. Balance the redox reaction by half cell method. Br2 plus H2O2 gives BrO3 minus plus H2O in acidic medium. So step 1 we write the equation and the oxidation number above each of the elements. For example, Br2 oxidation number is 0 in the reactant, but in BrO3 minus, the Br's oxidation number is plus 5. Similarly, hydrogen's oxidation number in the reactant is plus 1, but in product it is 0. So here Br2 is reaction is a oxidation reaction, and hydrogen peroxide to water, it is a reduction. In step 2 we write the equation separately. Br2 gives 2Br O3 minus, and H2O2 gives 2H2O, that is reduction half, and Br2 to BrO3 minus is oxidation half. So let us take the oxidation half, that is Br2 to BrO3 minus plus 10 electron. Then Br2 plus 6H2O gives 2 Br2O3 minus plus 10 electron, balancing the oxygen. Br2 plus 6H2O gives 2 Br2O3 minus plus 10 electron plus 12 hydrogen ion, balancing the hydrogen. Now the reduction half. So hydrogen peroxide H2O2 gives water, that is H2O, and H2O2 plus 2 electron gives 2H2O, balancing the charge and oxygen. Secondly, we'll balance the hydrogen, that is H2O2 plus 2 electron plus 2H plus gives 2H2O. This is balancing the hydrogen in the reduction half. Now balancing the total charge, that is Br2 plus 6H2O gives 2 BrO3 minus plus 12 hydrogen plus 10 electron, and H2O2 plus 2H plus 2 electron gives 2H2O multiplied by 5. So here also cross multiplication. So first one is multiplied by 1 and second one is multiplied by 5 for balancing the charge. What we are doing? We are balancing the charge. So the step 4 is Br2. Upon solving the equation from step 3, we get Br2 plus 5H2O2 plus 10 H plus 10 electron minus plus 6H2O gives 2 Br2O3 minus plus 12 H plus 10 electron plus 10 H2O. Upon solving, we get Br2 plus 5H2O2 gives 2 BrO3 minus plus 4H2O plus 2H plus. And this is the 4-step solution for balancing the equation by electron ion method or electron ionic method. Now let us see one more concept, that is calculation of EMF of a cell. Every galvanic or voltaic cell is made up of two half cells, the oxidation half cell, that is anode, and reduction half cell, that is cathode. E naught cell is equal to standard electrode potential of cathode, that is standard electrode potential of minus. So net EMF of a cell is equal to standard electrode potential of cathode minus standard electrode potential of anode. So in our case, E naught cell is equal to E naught cathode minus E naught anode. Let us see few problems. Question: the half cell reaction with reduction potential are PbS gives Pb2 plus aqueous. E reduction is equal to minus 0.13 volt. Ag solid gives Ag plus aqueous. EMF of reduction is equal to plus 0.80 volt. Calculate the EMF. So it is very simple formula. EMF of cell is equal to E cathode minus E anode. It gives the reaction silver is reduced and Pb lead is oxidized, and so we can write 0.8 minus bracket minus 0.13, which gives 0.93 volt. So let us solve few More question. So question is, balance the following redox reaction by ionic method: Cr2O7 minus 2 plus Fe plus 2, Cr plus 3 plus Fe plus 3 plus H2O in acidic medium. So step 1, just we write the equation whatever is given in the question, and step 2 we try to we write the reduction half, which is the reduction half, uh, Cr2O7 plus 6E, which is equal to 2Cr plus 3. This is the reduction half. And the oxidation half, Fe2 plus gives Fe3 plus 1 electron. This is the oxidation half. Balancing O, adding equal number of water molecule and H atom by adding H in the deficient site. So first we balance O by adding 7 molecule of water, and rest H is added by adding 14 H plus in the left hand side. Similarly, the below equation, the Fe equation, is multiplied by 6. So Fe2 plus gives Fe3 plus electron. This is multiplied by 6 as a cross multiplication. So upon combining these equations, we get a balance equation for this. So a stoichiometric uh, coefficient of sulfur when following reaction H2S plus HNO3 gives NO plus S plus H2O is balanced in acidic medium is A, option A 1, B, option B is 2, option C is 3, and option D is 4. The balance equation is written as, we write the balance equation, and the answer is C 3. So we multiplied by 3. So this is only this this is the option given in C. Let us see one more question. In the reaction Al plus Fe2O3 gives Al2O3 plus Fe, the number of electron transferred from reductant to oxidant is A, option A 8, option B 4, option C 16, option D 24. So first we write the both part of reaction, that is aluminum 8 aluminum part reaction, and second iron part reaction, Fe part reaction. So and upon solving we find that 24 is the correct answer, that is D. Why? Because 24 electron, which is balanced both the sides, which balance the ions for both the sides, gives the answer. So this is the end of today's class. Before closing this class, we request you to subscribe, like, and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you for supporting us and watching our videos. Please comment us and like us on our videos. Thank you very much.